Units. So here's an interesting sentence. When my son was 7, he walked 3, and when he was 4, he threw his baseball 8 and said his school was 5 away. Does that make much sense? It doesn't. Units are important. Numbers by themselves don't really mean very much. When he was 7, what? 7 days, 7 months, 7 years, 7 decades? Some unit of time, apparently. He walked 3, but he walked 3 miles. He walked for 3 hours. We don't know. If I remember correctly, this sentence is in your textbook. I think it was when my son was 7 months, he walked 3 steps, and when he was 4 years, he threw his baseball 8 feet and said his school was 5 miles away, or maybe it was 5 blocks away, I don't remember. Units make a big difference. You go to McDonald's. They say, well, what do you like? Well, what do you want to have? I'd like 2. They're like, you want number 2? No, I want 2. What are they going to give you? Nothing. You're like, well, you got 2 what, right? 2 coffees, 2 apple pies, 2 Big Macs. Units are important. Units make all the difference. Units are really important in chemistry. Okay. So there are 2 common unit systems, the English system and the metric system. So here in the United States, we use the English system, which ironically even the English don't use anymore. But we're just kind of stuck with it. Almost the rest of the world uses the metric system. The metric system is beautiful. And I hope that this semester I can help you understand how wonderful the metric system is. It may be strange to you, but once you get to know it, it's so much easier to use. So scientists use the International System of Units, or the SI units. It's SI because it's just like in Spanish, the French, pointing with the wrong thing again. The French do their words in different orders. So they say system international instead of international system. The international system and the metric system are virtually identical. The units and the prefixes and everything are the same. The main difference is what they call their base unit. To me, that difference is completely unimportant. So I recognize that they are different, but I'm going to treat them as though they were the same. So here are some metric units. Length is measured with meters, mass with kilograms, time with seconds. That one's at least familiar. Temperature is measured in kelvins, and we'll talk more about that in chapter 3. So these units, the meter. The meter is, actually this is funny because this is a yardstick. You don't see those too much anymore. That's a yardstick. A meter stick, there's some over under the fire blanket over there. A meter stick is about 3 inches longer. So a meter and a yard are pretty similar in size. And that's how they define the meter. It used to be the length of a bar of iridium or something, and they changed it now. It's defined in terms of the distance that light travels in a very short period of time. Now that's the meter. Standard unit of mass is the kilogram. That's a picture of the official kilogram. And that's located at the International Bureau of Weights and Measures in France. The kilogram is roughly in the same ballpark as a pound. So 1 kilogram is about 2.2 pounds. Don't use that for calculations or anything, but that's just 2.2 pounds. Seconds, these are the same seconds that we're familiar with, the little ticks of the clock. Scientists define them a little more specifically, though, and you can read that. We define it in terms of radiation being emitted from a certain type of radioactive atom. The kilogram is a unit of mass. Mass and weight are not the same thing. Mass measures quantity of matter in an object, and weight measures gravitational pull. if you travel to the moon, your weight changes, your mass does not. If you took a bathroom scale, which measures weight, to the moon, you would find that you weigh 1/6 less on the moon. So that'd be kind of cool. Does that mean you got skinny? No. It just means that the moon, being smaller, is going to have a lesser gravitational pull, and it's going to pull you to itself less. You come back to the Earth, you're going to weigh the same as you did before you left. Your mass doesn't change. The amount of matter in your body doesn't change. So kilogram is a unit of mass. Gram is also a unit of mass. The English pound is actually a unit of force. It measures the gravitational pull. So I'm telling you, they are intrinsically different, but sometimes we still use the word weigh. Like in a lot of the lab things, they'll say weigh your substance and record its mass. Okay, prefix multipliers. On the list of things I'm asking you to memorize are some of the metric prefixes. And these prefixes change the size of the metric units. In the English system, we have feet and inches and yards and miles. Let's say I'm going to measure the length of this pen. Would I use miles to measure that? No. Would I use yards? No. I probably wouldn't even use feet. I would use inches. Because we want to use a unit that is similar in size to what we're measuring, or a little bit smaller, so that we can say, oh yeah, well that's 5 inches instead of 0.0005 miles or some crazy thing like that. And then, so we have these different sized units because we need different sized units. In the English system, they're related by basically random numbers. 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile. There's really no rhyme or reason to those numbers. And that's because those units came about and have evolved from ancient times. A foot was originally the length of the king's foot. You got to pick some way to measure things, and so they chose these things, right? And different countries defined them differently. It was a big old mess. The metric system came along when scientists, had a better idea of what do we need to do with these things, and it's a lot more organized. But as Americans, we're all used to doing this, and we're just going to do it our way, right? So we're still fighting the metric system. So instead of having different units for different sizes, we just have prefixes that multiply the unit so that you get the size you need. So here's a table of some of the more common metric prefixes. There are others. So a meter is pretty long, okay? A meter is a little bit longer than this. Would that be a good unit to measure the length of that pen? No, we need something smaller. So we could put the prefix centi in front of it and get a centimeter. A centimeter is 0.01 of a meter, 1/100th of a meter. How many cents are in a dollar? 100. How many years are in a century? 100. Okay, that prefix cent has to do with 100. A centimeter is 1/100th of a meter, and a centimeter is like this long. So that's good for measuring the length of a pen. If I'm going to measure the distance between here and Minnesota, am I going to use centimeters? No. How about meters? Those are bigger. Still too small. How about kilometers? A kilometer is 1,000 meters. Kilo means 1,000. So a kilometer is 1,000 meters. What if I need something even bigger? We use these prefixes in the computer industry. We used to measure storage devices in terms of like kilobytes and even and megabytes, you know, and a 2 megabyte hard drive was pretty good. And now you're like, that's the size of a file I need to send you by email, right? So, but mega means a million. Now we're seeing things that are giga and tera. My computer has a 1 terabyte hard drive. That's mind-boggling. A terabyte is 10 to the 12 bytes. It's a 1 with 12 zeros after it. This guy right here. That's a lot. But that gives us a unit that's nice to work with when we're doing that large of a quantity. So the ones you need to memorize are the ones on that list. So I don't think mega was on there. Is it? Okay, so mega and kilo and centi, milli, micro, and nano, I think. Pico we don't use very much. Femto in chemistry, at least general chem, really not at all. Deci is a great unit, but we don't really need it in chemistry. Notice that the symbols correspond to the first letter of the word. But we have 3 that start with M. There's mega and milli and micro. Mega makes the unit bigger. Megabucks, mega means a million. So megabucks is $1 million. Mega is a capital M. It's a big unit, it's a big M. Milli makes a unit smaller. It's 1/1000th. Milli is a small m. We ran out of m's. So we're using the Greek m for the next one, micro. So this is the Greek letter mu. And it looks like a U, doesn't it? But it's got a tail on the front. So become familiar with him. We're going to use him quite a bit. So that's micro. This is what they mean. This is the multiplier in decimal form. And these guys in the middle, that works out okay. But when you get very far out, it becomes unwieldy. And so this is what I really want you to memorize, is the powers of 10. And if you notice, most of the exponents have 3 as a factor. 3, 6, 9, 12. 3, 6, 9, 12, 15. It's just these couple guys in the middle that are a little weird. But centi is 1/100th. Any questions? The beautiful thing is, you'll learn the prefixes. You can do anything with metric units. Any relationships. Does anybody, just off the top of their head, know how many teaspoons are in a gallon? No. We could figure it out, but we'd have to do a bunch of things, right? Metric system, it's easy to go between 2 random units. At most, it'll take you 2 steps. So it's a beautiful, beautiful thing. Okay, so we have a short chemical bond. It's about 1.2 times 10 to the minus 9 meters. We want a unit that's going to be about that size. What prefix should we put on meter to make it that size? Nano. Because nano means 10 to the minus 9. So 1 nanometer equals 10 to the minus 9 meters. So in nanometers, this would be 1.2 nanometers. So we use the metric prefixes to scale the units to be appropriate to what we're measuring. Any questions? We also have derived units. Derived units are derived from other units. Many of the volume units are this way. If we take a block of wood and want to know the volume of it, how do we calculate the volume? We could measure the dimensions and multiply, right? Remember from geometry class? The volume of a rectangular solid is the length times the width times the height. So what if this was a large block of wood and we measured these in meters? What unit would we end up with for the volume? Meter times meter times meter is what? Meter cubed. Units are like variables. They multiply together. They can cancel out. So we end up with meter cubed. So any unit of length, meters, inches, miles, can become a unit of volume if it's cubed. So we got cubic meters, cubic centimeters, cubic millimeters. Those are all derived units of volume. Liter is not a derived unit. A liter is generally used for liquid volumes, but that's the metric unit of volume. And then milliliter, what does milli mean? It means 1/1000th. So 1/1000th of a liter. Do you know what a liter looks like? Roughly how big it is? I know what 2 liters looks like. Right? 2-liter bottle of soda, right? So 1 liter is half of a 2-liter bottle of soda. A milliliter is 1/1000th of that. So it's just a little bit. It's a small unit. And that's great for measuring small quantities of liquids like we might use in the chemistry lab. We're not going to use liters of sulfuric acid or something. We do things on a smaller scale.